Welcome back. Today we are going through lesson 3.5, which is all about transformations of functions. So we learned about functions, now we're going to transform them. A transformation of a function is an alteration, so a change of the function rule or the equation that results in an alteration of its graph. So something we change about the equation is going to change what the graph of that function looks like. There are 4 types of transformations that we're going to talk about. The first one is a translation, which is where we just move the graph left or right. The second one is a compression. The third one is stretch. And the fourth one is reflections. So in this lesson, we're going to use absolute value as kind of our example, but you can use this on many different types of functions. So the absolute value function is just what we're using here because it makes it a little bit easier to see things. All right. So we're going to combine some transformations in order to figure out what's going on here. So the first thing we're going to do is we are going to identify the vertex. So the vertex is coming from the x value that would make the inside equal 0, and then the y value outside. So this is your h, and this is your k. So in this case, what I would plug in for x to make that absolute value equal 0 is -1. So the x value is -1 and the y value is 3. So notice that that x value is kind of that opposite. All right, then we're going to determine if there's a reflection. So to determine if it's a reflection, we look on the outside here, and if it has a negative out in front, then yes, it does have a reflection. If the first number is positive, then it does not have a reflection. Then we're going to use the a value. So the a value is that number in front of the absolute value. So in this case, it's 1/2, and we're going to use that like slope to plot more points. We have to remember that this is going to make a V shape. So we're going to go positive slope to the right, negative slope to the left. All right, so here's what we're going to do. We're going to plot that vertex at -1, +3. And then we're going to go to -1/2. So down 1 over 2 or down 1 right 2 to make that V shape. And then you can keep going down 1 right 2, down 1 left 2, and then down 1 right 2. And you can kind of start to see that V shape form here. And you can keep going until you reach the edges of the graph. And then you're going to connect that and make that V shape like that. So that's how we graph them. All right, now we're going to look at some equations. We're going to change the absolute value in order to do that. So before we do those things, let's talk a little bit about all the transformations that can happen. So I'm going to skip ahead here and zoom out a little bit. So these are all the possible transformations of an absolute value function. So like I said, there's kind of 4 that we're talking about. There's the translations, stretches, compressions, and reflections. So let's go through these a little bit and see kind of what would it look like on an absolute value function. So remember up in that top left corner, that's the parent function of the absolute value. That's the graph before we transform it at all. That's just a basic absolute value of x graph. So the first thing that can happen is we can have a vertical shift. So a vertical shift is where we move the graph or down. So for this first one, we would move the graph up 3. So that means instead of starting at 0, 0, it starts up 3. And then it has that same slope of up 1 over 1. So same shape, just shifted up 3. Then we also have a -4. So that means it's going to shift down 4, which means that instead of 0, 0, we're going to start down at -4 on the y-axis, but then continue with that same slope up 1 over 1 in both directions. So same V shape, just move down 4. We can also horizontally shift things. We already vertically shifted. So a horizontal shift, you'll see that changes the x values. So a shift left 2, remember we talked about it's actually about what would make that absolute value 0. So -2 is what would make that 0, and that shifts it left 2. So instead of starting at 0, 0, it starts over here at -2 on the x-axis, goes up 1 over 1 in both directions. Then we have the inverse of that, which is a shift or a translation 5 units to the right. So again, it would be positive 5 minus 5 that makes it 0, so that's why it goes right 5. So if I go over from 0, 0, right 5, there's my vertex point, and then it's that same V shape still, up 1 over 1 in both directions. All right, so those are all the translations. We can move it up, down, left, or right. Then we have dilation. So this is your stretches and your compressions. A stretch is when we multiply the whole function out in front by something greater than 1. So any number greater than 1. So in this case, in our example, we're going to stretch it by 4 by multiplying by a factor of 4. So that means that it still starts at 0, 0. Doesn't change that. But instead of going up 1 over 1, up 1 over 1, we're going up 4. So we're stretching it vertically. Up 4 over 1, up 4 over 1. So you can see that it gets kind of skinny there. It makes the V shape much narrower. And then our second one is kind of the opposite of that. So here we have a compression. That's where we multiply out in front by a number between 0 and 1. So a fraction, decimal, any number between 0 and 1. So for example, if we multiply by 1/2, that means that I'm starting at 0, 0, but I'm going up 1 over 2. So it's going outward more than it is upward. Up 1 over 2. So it's much wider. We call that a compression. So we're compressing it from the top, which is making it go wider. Okay. And then lastly, we have reflections. So reflections are where we put that negative out in front. And when we do that, it reflects it over the x-axis. So our absolute value, when we reflect over x, starts at 0, 0. But instead of going above the x-axis, now we're below the x-axis. Same slope, though. Down 1 over 1. And then lastly, we can also reflect over the y-axis. So that's where we multiply by a negative inside the absolute value function. So it would look like that. And that's where we flip it left to right. So everything that was on the right is now on the left side. Everything that was on the left is now on the right. And what you'll notice in an absolute value function is that that looks the same. It doesn't really change the look of it. The x or the y values are switching signs. Since this one's symmetric that way, it doesn't really change much. So those are what the transformations kind of look like. Let's go back and use those now to actually write some equations. So for number 1 here, asks us to write an equation with a vertical stretch by a factor of 4 and a reflection over x. So thinking back, hopefully you have that sheet to refer to. A stretch by a factor of 4. That means that we're going to multiply by a 4 out in front of our absolute value of x. And then we also have a reflection over the x-axis. Remember, a reflection over the x-axis means that we're multiplying the whole function by a negative. So our new equation would be y equals negative 4x. Okay, let's do the next one. So y equals still, and I'm going to have an absolute value of x in there. Let's see what we need to add for this one. So this one is saying to translate it 5 units. So thinking back up, 5 is added on the end. And then it's compressing by a factor of 3. So that means that I'm going to put a 3 out in front. So that would be my final equation for that one. Okay, our next one is y equals, we know we're going to have an absolute value of x. We're going to translate it right 4. And if you remember, translation right 4 means that inside that absolute value, we're going to need to subtract 4. So we subtract 4, remember, because it's right 4 means that we're at positive 4 for x, not for what's in the equation. And then we're going to go down 3. So down is minus 3 outside. And then we have a stretch by a factor of 6. So that means a 6 goes out in front on that one. All right, and finally for example 4, we know we have our absolute value of x. On this one, we have a translation left 2. So that means I'm going to add 2 to the x values to translate it left 2. We know it's going 6. So that's where that comes in at the end. And then on this one, we have a reflection over x again. So remember, that means I add a negative out in front. On this page, we have talked about how to graph when we're given the equation. We've talked about how to write the equation when we're given the transformations. The last thing that we're going to do today is we are going to be given a graph and we're going to write the function. So on this, we want to remember that the parent function with no transformations on it for absolute value is centered at 0, 0, and is going up 1 over 1 in each direction. So sometimes having this on there kind of helps me to visualize what's going on. So the first thing we're going to do is we're going to identify any translations. Translations are moves up, down, left, or right from that 0, 0. So for that, I'm going to look at this key point that is the vertex there. So I can see that from 0, 0, it is shifted right 2. And then I can also see that it is shifted up 6. So remember, that's where my vertex is. That means that my vertex is at 2, 6 from where it was before. That, remember, is going to be my h and k value in my equation. Then it says to determine if there is a reflection. And I can see on this one that it is upside down, so that's a reflection over x. And then I'm going to check my slope. And that's going to tell me if there is a stretch or compression at all. So if I look from that vertex, the nice point that I can see here, kind of going in each direction, is let's see, down 1, 2, 3, 4 over 1. So that means that the slope in this case is 4. And I didn't write the negative because the negative is taken care of with the reflection. So from that, I am going to create my function. So I know that it is going to have y equals, and I'm going to have an absolute value of x. And now we're just going to fill everything in. So I have a shift right 2 that goes in there with the x, and up 6 that goes on the end. I'm going to have a reflection out in front, so that's a negative. And then my slope is 4, which means I have a stretch of 4 out there in front. So again, those are all the transformations we can do, and you have this sheet to kind of help you. I want to make sure you see in this top right corner, this has that equation with a h and k in it for you to refer to, and to remind you that the vertex is at h, k. Those are all your transformations of functions. We'll see you next time.